Darkness fills the screen, a cold, silent, endless nothing. No stars, no planets, no galaxies, not even empty space. Only a deep black void that stretches forever. The narrator speaks softly, like telling an ancient secret. In the beginning, there was nothing. The darkness remains still. For a moment, time itself feels frozen. Then, in the center of the emptiness, something begins to glow. Tiny point of light, so small it looks almost like an illusion, shimmers in the black void. No one knows why it appeared. No one knows what came before it, but this was the beginning of everything. The glowing point starts to shake gently as if it is alive. It pulses with a warm, golden light. Each pulse grows stronger. The audience can sense energy building as though a storm is gathering inside a grain of dust. The narrator continues. Scientists call this moment the Big Bang, a single event that turned nothing into the universe. Suddenly, the tiny point explodes. Light floods the darkness. Fire, energy, heat. A blast so powerful it creates space itself. A wave of brightness expands in all directions. It is not just an explosion, it is creation. Matter flies outward like sparks from a cosmic fire. Space stretches like a rubber sheet being pulled from every side. The universe is born in a flash so bright that even imagination struggles to contain it. The narrator speaks over the violent beauty. In less than a second, the universe grew faster than light. It expanded billions of times in size, filling with intense heat, raw energy, and chaos. There was no up, no down, no shape, no sound, only pure creation. Clouds of glowing particles swirl like storms. They smash into each other, forming new materials. The early universe is not peaceful. It is wild, dangerous, unpredictable. But within this storm, the first seeds of everything begin to form. From this chaos, tiny building blocks appeared. They would one day become stars, planets, and even life. The screen zooms out, showing the universe expanding like a giant balloon. Waves of color ripple across space, mixing reds, blues, and bright white flashes. But suddenly, everything begins to slow. The fire cools. The brightness fades. A soft, calm darkness spreads again, but this time the darkness is not empty, it is full of possibility. 300,000 years later, the universe finally cooled enough for light to move freely. The darkness began to shine. A soft glow fills the cosmos. Clouds of early matter begin to drift. They collect into larger shapes pulled together by gravity, an invisible force that begins to design the universe. Then something spectacular happens. A bright point appears inside one giant cloud. It grows brighter and hotter. The cloud around it tightens, squeezing the glowing center. And then a star is born. Fire erupts from the center as nuclear fusion begins. The first star shines like a cosmic torch, lighting the darkness for the first time in history. He watches the first star ignite. A single sun in an ocean of black. It burns with a power stronger than anything that had existed before. More stars appear, thousands, then millions. They gather into giant spirals, forming the first galaxies. Brilliant rivers of light stretch across space. What was once empty darkness now becomes a playground of shining worlds. But deep inside some of these early stars, danger is growing. Huge stars, much larger than our sun, burn their fuel too quickly. Their cores grow unstable. The screen shows a massive star trembling. Light flickers across its surface. When a massive star dies, it does not simply fade away, it erupts. The star collapses inward. The pressure becomes unimaginable, and then an explosion fills the cosmos. A supernova brighter than an entire galaxy blasts matter in every direction. But the most mysterious thing happens at the star's heart. The collapsed core does not disappear. Instead, it shrinks smaller, smaller, smaller until it becomes a tiny, dense point. A black hole. A dark sphere forms, bending the space around it like a whirlpool. This is a black hole, a place where gravity becomes so strong not even light can escape, a cosmic trap that hides everything it touches. The narrator's voice lowers as the camera moves closer to the black hole. Stars around it stretch and distort like reflections in a broken mirror. Time slows near its edge. Space curves inward. If he were to cross the event horizon, the point of no return, he would never come back. Time itself would behave differently. Physics would break. The universe's rules would collapse. The black hole spins slowly like a dark storm with glowing rings around it. Gas falls inward, heating up and shining with deadly light. Yet the center remains completely black, silent, unknowable. Black holes are not only destroyers, they may also hold secrets about the beginning of time and the end of everything. The story cuts back to the early universe, where galaxies continue to grow, stars group together. Solar systems begin to form. Dust spins into planets. Moons settle into orbits. The universe becomes more structured, more organized, more alive. But the narrator brings a new mystery. If black holes swallow everything, why do galaxies survive? In fact, why do they grow larger around black holes? This is one of the greatest puzzles in the universe. The camera shows a supermassive black hole at the center of a young galaxy. It hums like a giant engine. Gas and stars circle it in spirals. Every large galaxy has a giant black hole at its center, including our own Milky Way. Without them, galaxies might not form at all. The narrator pauses, letting the audience absorb the thought. Then the scene shifts again, back to the very beginning, the moment of the Big Bang. Flames and light burst across the screen as the universe is born all over again. But the greatest mystery remains. Why did the Big Bang happen? What caused everything to begin? And what existed before? The camera moves through cosmic clouds, passing newborn stars and galaxies. It glides through glittering clusters and colorful nebulae. The universe looks alive, growing, changing, evolving. Yet every step deeper brings more questions. If the universe had a beginning, will it also have an end? Will everything collapse into darkness again, or explode into something new? A silent scene follows, galaxies drifting apart, space expanding, stars slowly burning out. The narrator continues. Scientists believe the universe is still expanding today. In fact, it is expanding faster than before. Something strange, something invisible, is pushing everything apart. The audience sees galaxies like small islands floating away from each other. He wonders what this force is. Some call it dark energy, a mystery stronger than gravity itself. But the narrator does not answer the question. Instead, he builds suspense. If dark energy keeps growing, the universe may end in a cold, empty future, or it may tear itself apart in a violent event called the Big Rip. The tone becomes darker. Stars fade on the screen. Galaxies stretch. Space becomes thin, then bright light again. We return to the present universe. Stars shine beautifully. Nebulae glow with color. The Milky Way spins like a cosmic dance. But for now, the universe is alive, full of light, motion, and wonder. The music rises softly. He begins a journey through everything we know and everything we do not know. From the first spark of the Big Bang to the deepest mysteries of black holes to the hidden forces shaping the future of the cosmos. The narrator's voice becomes dramatic. This is not just a story of space. This is the story of existence, the story of us. The screen slowly zooms into a galaxy. Welcome to the universe's greatest mysteries. And the scene fades out, darkness returns to the screen, but this time it is not empty. A soft glow moves across space like a slow whisper of light. Stars shimmer in the distance, floating in endless silence. But in the middle of this peaceful scene, something strange bends the starlight. Something invisible pulls at the space around it. The narrator begins. In the quiet corners of the universe, there are monsters. Not monsters of myth, but monsters of gravity. The camera draws closer to a region where the stars look stretched, twisted, distorted like reflections in rippling water. At the center of this distortion lies a deep, perfect black circle. No light reflects from it. No color escapes. It looks like a hole punched into space itself. This is a black hole, the most powerful, mysterious, and frightening object in the universe. A soft vibration hums through the scene, almost like the universe is holding its breath. The narrator continues. A black hole begins with the death of a star, but not every star, only the giants. The screen changes. A massive star 10 times larger than our sun burns brightly in rich hues of blue and white. It roars with energy, sending waves of heat into space. A star shines because it burns fuel at its center. Fusion pushes outward while gravity pulls inward. As long as these forces balance, the star lives. But slowly, the brilliant star flickers. Its surface shakes. Deep inside, its fuel is running out. When the fuel ends, the balance is broken. Gravity wins. The star begins collapsing inward. The audience sees the surface fall toward its own center, becoming smaller and heavier. Within moments, the collapse becomes violent. Then, a tremendous explosion fills the screen. A supernova lights the universe like a cosmic bomb. Waves of color and debris shoot outward like fireworks. The outer layers of the star blow apart in a spectacular explosion, but the core, the heart of the star, is crushed. The glowing core shrinks again, smaller, smaller, impossibly small, until it becomes a point of infinite density, a black hole. Here, gravity becomes so strong that nothing escapes, not matter, not light, not even time. The screen fades to the dark sphere once more. Around it, a glowing ring of gas swirls at extreme speed, orange, blue, white, all rotating like a furious whirlpool. Anything that comes too close begins a deadly dance. First it is pulled, then stretched, then ripped apart. The camera follows a piece of drifting gas as it moves closer to the black hole. At first nothing happens, but slowly it begins to spin, faster, faster. Soon it heats up and shines bright as a star. This swirling ring is called an accretion disk. It is the last light that matter gives before it disappears forever. The narrator pauses for dramatic silence. But what happens to the matter after it falls in? Where does it go? The audience stares into the black center. It looks peaceful, calm, empty. Yet the narrator reveals the truth no one knows. Beyond this invisible boundary called the event horizon, everything becomes unknown. Physics breaks. Time bends. The rules of the universe do not work the same. The screen zooms in until the edges blur, giving the sense of being pulled inward. But just before crossing the event horizon, the scene shifts. We move far away to the center of a galaxy. Stars swirl in a magnificent spiral, beautiful, massive, alive. Every large galaxy has a black hole at its center. These are not normal black holes. These are giants, millions or even billions of times heavier than our sun. The camera enters the glowing heart of the galaxy where a supermassive black hole sits like a dark king. Around it, stars orbit like fireflies caught in a gravitational dance. For years, scientists thought black holes only destroy, but now they know black holes also create. The narrator continues in a mysterious tone. Without supermassive black holes, galaxies might not form at all. We watch particles move around the black hole, shaping gas clouds, pulling matter together, guiding the structure of the galaxy. A black hole's gravity organizes the chaos. It helps galaxies grow, spin, and stay stable. It is a surprising truth. Black holes are not just monsters, they are architects. The camera now moves to a distant region of space where two stars orbit each other peacefully, glowing like twin suns. But nearby, an invisible force begins to pull them apart. Black holes do not stay alone forever. Sometimes they collide. Another black hole appears. The two dark spheres drift toward each other, slowly at first. Then faster, they orbit, twisting the fabric of space like waves on water. Their dance sends ripples across the universe, ripples called gravitational waves. A deep bass sound vibrates, representing the waves traveling outward across millions of light years. These waves were detected on Earth only recently. They prove that black holes crash together in cosmic events powerful enough to shake the universe. The two black holes finally merge, becoming one even larger, darker monster. A quiet calm settles. The narrator speaks softly. He watches the universe change, shaped by invisible giants. But the story continues. Far away, a small star wanders too close to a black hole. It is peaceful, unaware of its fate. But the black hole's gravity begins pulling one side of the star harder than the other. A bright flare appears. This process is called spaghettification. The star is stretched into a long, thin shape like space pulling it into a noodle. The star tears apart completely. Half of its gas spirals into the black hole, the rest shoots into space as a glowing arc. It is terrifying and beautiful. To the universe, destruction is also creation. The star's broken pieces will become material for new stars, new planets, new life. The camera follows one stream of glowing gas drifting through space, eventually mixing with a cloud where new stars are forming. Black holes destroy, but the universe rebuilds. Now the narrator deepens the mystery. Some scientists believe black holes may not be endings, but gateways. The idea hangs in the air. There are theories that a black hole's center may lead to a white hole, an opposite cosmic object that throws matter out instead of pulling it in. A white hole appears on the screen, bright, explosive, impossible. Material sprays outward like fountains of light. No white hole has ever been found, but the idea suggests something incredible. Black holes might be portals to other regions of space or even to other universes. The camera shifts to show a black hole's interior as imagined by science, a swirling maze of warped space where time slows near the edge and completely breaks inside. Inside a black hole, time may stop, space may fold. The past and future may mix. The narrator does not claim certainty. Instead, he offers awe. No one can see inside a black hole. No message can escape. Every theory remains a mystery sealed in darkness. The screen now transitions to the real universe again, a place full of stars, planets, and glowing nebulae. For decades, humans only imagined black holes. They were mathematical ideas, not proven objects. Then the scene changes to 2019. A blurry orange ring appears. Until the world saw this. The first ever image of a black hole, captured by the Event Horizon telescope, glows like a flaming ring surrounding a dark center. For the first time in history, humanity looked at the face of a black hole, a shadow printed on light itself. The narrator speaks with wonder. This image confirmed what many believed: black holes do exist. They are real. They shape everything. The screen fades to a wide shot of the universe again, galaxies spinning, stars forming, planets drifting silently. Black holes are not rare. The Milky Way alone has millions. and somewhere in the center of our galaxy, one giant black hole sits quietly, watching over us. Sagittarius A*, the black hole at the Milky Way's core, appears on screen dark, calm, humming with hidden power. Luckily, it is far away. Earth is safe. But the existence of this giant reminds him that the universe is full of forces far beyond our understanding. The narrator's voice deepens for suspense. What if a black hole passed near our solar system? What would happen to Earth? The screen shows a simulation, planets being pulled, orbits breaking, the sun itself twisting as the black hole disturbs space. It is frightening, but the narrator reassures this will not happen. The nearest black holes are too far to harm us, yet the possibility shows how fragile our place in the universe is. The scene softens. Stars twinkle gently. Space becomes peaceful again. Even after everything humans have learned, black holes remain one of the universe's greatest mysteries. A final wide shot of the swirling universe fills the screen. They destroy, they create, they bend space, they shape galaxies, they hide the deepest secrets of time. The narrator ends with a powerful line: to understand black holes is to understand the universe itself. Fade out, a soft, glowing mist fills the screen. It swirls slowly, like the breath of the universe itself. Light pulses gently inside the mist, rising and falling like a heartbeat. The narrator begins. To understand the universe today, he must return to the beginning. Not the beginning of stars, not the beginning of galaxies, but the beginning of everything. The glow fades away, leaving pure darkness, a silence deeper than anything imaginable. No movement, no sound, no space, no time. Before the universe existed, there was no before, there was only nothing. A single point of light appears at the center of the screen. It is impossibly small, smaller than an atom, smaller than a grain of dust. Yet inside this tiny point rests all the energy, matter, and laws that will one day shape the entire universe. The narrator speaks with quiet awe. This point was incredibly hot, incredibly dense, a state humans cannot imagine, but something unimaginable was about to happen. The point begins to vibrate. Small shakes become violent tremors. A high-pitched ringing fills the air. Then a blinding flash, explosion, expansion, creation. This was the Big Bang, not a normal explosion, but the birth of space, time, and everything that would ever exist. Waves of color sweep across the darkness. Space stretches in all directions at unimaginable speed, as if the universe is taking its first breath. The narrator continues. In a fraction of a second, the universe grew faster than light. It expanded from smaller than a particle to the size of a galaxy. Shapes swirl, clouds twist, fire burns across the newborn cosmos. But this early universe was not beautiful. It was violent, chaotic, and wildly hot. Particles smash into each other like bullets. Energy storms blast through the cosmic fog. There are no stars, no planets, no structure, only pure exploding creation. Star the young universe. A wild, blinding storm. The screen fills with flashing particles, tiny points of energy swirling like sparks from a cosmic fire. For the first few minutes, the universe was a boiling sea of plasma. Temperature, trillions of degrees, pressure, unimaginable. The particles collide, merge, break apart, and merge again. The narrator explains in simple words. These tiny pieces were the first building blocks of matter, the ingredients for atoms, the ingredients for everything. Slowly, the universe cools enough for these pieces to join together. Hydrogen forms, then helium. The earliest simple elements drift through space like glowing dust, but the universe remains dark. No stars exist, only gas. For almost 400,000 years, the universe was like a fog. Light could not pass through it. The screen becomes cloudy, hazy, thick. Then the fog begins to clear. Light escapes. This moment is called the cosmic microwave background, the first light of the universe. The screen shows a soft, colorful glow spreading across space. Gentle reds, blues, and yellows paint the darkness. Scientists call this the baby picture of the universe, a snapshot taken when the universe was still an infant. Star gravity takes control. The first structures, now dust and gas, drift in the early universe, but something invisible begins to shape them. Gravity. Small particles start pulling on each other. Tiny clouds grow into larger clouds. The larger clouds attract more mass. Soon, giant structures begin to form. Gravity is the universe's sculptor. It takes chaos and turns it into order. A giant cloud collapses inward, its center heats, pressure builds, the screen shakes. A bright flash erupts from the middle. The first star is born. It shines blue-white, hotter and brighter than most stars today. More stars follow, thousands, millions. They gather into clusters. The clusters gather into galaxies. The camera zooms out to show the early universe forming its grand shape. Only a few 100 million years after the Big Bang, the first galaxies began to glow. They are small, irregular, messy, but beautiful, tiny islands of light in a dark, cosmic ocean. Star birth of galaxies. The universe finds its shape. The narrator describes the growing universe. Some galaxies grew by merging with others. Some were torn apart. Some were stretched into spirals. Galaxies collide in slow motion. Stars scatter like sparks. Gas clouds twist into long, bright streams. Even today, galaxies continue to collide. The Milky Way itself is on a path toward a future collision with the Andromeda Galaxy. The screen shows a simulation of the future collision, two spirals merging into a giant cosmic structure. Then we return to the early universe where galaxies are forming their first stars. Stars were the universe's first creators. Inside their hot cores, new elements were formed. Carbon, oxygen, iron, the ingredients for planets and life. Star universe defined by uncertainty despite the progress. Narrator reminds the audience, there is still a mystery. What caused the Big Bang? The screen fades to darkness again. The small glowing point reappears. Some scientists believe the universe came from a quantum fluctuation, an energy bubble that suddenly expanded. A shimmering bubble pulses, grows, and bursts. Some believe our universe is one of many, a multiverse where bubbles of reality appear and disappear endlessly. Dozens of glowing bubbles float in a dark dimension, some bursting, some merging, some expanding. Others believe space and time may have existed in a different form before the Big Bang, and the Bang was only a transition. A cosmic cycle plays expansion, contraction, rebirth. The narrator adds, but these are theories. The truth remains hidden behind the universe's earliest moments. Star time itself begins. The narrator shifts tone. The Big Bang did not just create matter, it created time. Clocks appear, melting and twisting, showing that time behaves differently in extreme conditions. Before the Big Bang, time had no meaning, no seconds, no minutes, no past or future. When the universe expanded, time began flowing like a river. The screen shows a river of stars moving forward. Every moment in history, the birth of stars, the rise of galaxies, the creation of Earth, the future of humanity, exists because time began that day. The universe expands forever. The camera moves through modern galaxies, past nebulae, past star clusters. All of them drift apart slowly. Even now, 13.8 billion years later, the universe is still expanding, but something strange is happening. Galaxies move faster than expected. Their speed increases as distance increases. Something unseen is pushing them apart. Scientists call it dark energy. A mysterious purple haze spreads across space, gently pushing galaxies away from each other. The narrator continues, dark energy makes the universe grow faster with time. No one knows what it is. No one knows why it exists. Will it stop? Will it grow stronger? Will it destroy the cosmos? The questions are left unanswered. The birth of everything that will ever be. The camera zooms out slowly, farther, farther, until the entire observable universe becomes a glowing sphere of galaxies. The narrator speaks with emotion. Every star, every planet, every atom in your body, every piece of life, every idea, every dream, everything came from the Big Bang. The glowing sphere pulses with light. We are made from the universe. We are children of a cosmic explosion that happened nearly 14 billion years ago. Silence returns for a moment. Then the narrator adds, but creation did not end with the Big Bang. The universe continues to change, continue to evolve, continue to surprise. Fade into a star nursery where baby stars glow inside colorful gas clouds. The greatest mystery remains. The narrator ends with a powerful cinematic line. The Big Bang was the beginning of the universe, but it was also the beginning of all mysteries. The glowing point reappears one last time. What started it? What existed before? Will it happen again? The screen fades to black. To answer these questions, he must explore the universe's invisible forces, and the greatest of them all has no light at all. The screen opens on a quiet, peaceful view of the night sky. Stars shine softly, scattered like diamonds across a black canvas. The Milky Way stretches faintly from one side to the other, glowing with delicate light. The narrator begins. He looks at the stars and sees beauty. But what he cannot see is far greater. The camera zooms out slowly, showing the same sky from far above the Earth. The planet becomes small. The solar system becomes a tiny dot. The Milky Way appears as a giant swirling spiral. Then the narrator reveals, everything humans can see, every star, every planet, every galaxy makes up less than 5% of the universe. The screen freezes. A glowing sliver represents the visible universe. The rest turns dark. The remaining 95% is invisible, hidden, unknown, yet it shapes everything. A soft, mysterious hum echoes through space. This unseen world is made of two great mysteries, dark matter and dark energy. Star dark matter, the hidden skeleton of the universe. The camera takes the viewer inside a galaxy. Stars orbit the center in graceful curves. Bright clusters glow like lanterns. Everything seems predictable and stable. But then something strange appears. Stars on the outer edges move faster than they should. Instead of slowing down, they race around the galaxy as if pulled by an invisible force. The narrator explains simply, according to physics, stars far from the center should move slowly, but they don't. They move too fast. Something is holding them together. A transparent blue halo appears around the galaxy, large, soft, and invisible. Scientists discovered that galaxies are surrounded by invisible mass. Mass that does not shine. Mass that does not absorb light. Mass that cannot be seen. This invisible mass is dark matter. The narrator's voice deepens. Dark matter acts like a skeleton. It holds galaxies in place. Without it, galaxies would fly apart. The camera shows a galaxy without dark matter. Stars scatter in different directions like dust blown by wind. Then it shows a galaxy with dark matter, stable, balanced, strong. The narrator continues. Dark matter does not interact with light. Humans cannot see it, touch it, or detect it directly, but its gravity reveals its presence. The screen displays a map of the universe. Blue filaments stretch across it like a vast cosmic web. Dark matter forms a giant web across the universe. Galaxies grow along its threads. Stars form inside its structures. Dark matter shaped the universe we see today. The camera moves along one of the glowing threads. Tiny galaxies cling to it like jewels on a chain. Start the search for the invisible inside a high-tech laboratory. Machines hum quietly. Scientists watch screens filled with strange patterns and graphs. For decades, humans tried to detect dark matter. They built powerful detectors deep underground, hoping dark matter particles would reveal themselves. The screen shows a large underground chamber, silent, glowing faintly blue, but nothing happens. Dark matter stays hidden. It passes through planets, stars, and even humans without leaving a trace. The narrator gives a simple explanation. Imagine billions of particles moving through you every second, and you cannot feel a single one. The camera shows tiny particles of dark matter streaming through Earth like ghosts. Still, the mystery continues. Some scientists believe dark matter is made of unseen particles. Others think it may be something stranger, like hidden dimensions or unknown forces. But no one knows for sure. The narrator adds suspense. Dark matter is not just invisible. It is silent. It keeps the universe together, yet remains the universe's greatest secret. Star dark energy, the force that tears the universe apart. The camera now zooms far out into deep space. Galaxies drift peacefully in the darkness. Their soft glow fills the screen with cosmic calm, but something begins to change. The distance between galaxies increases, slowly at first, then faster. In the late 1990s, scientists made a shocking discovery. The universe is not just expanding, it is expanding faster over time. Galaxies pull away from each other like leaves drifting on a widening river. This meant something was pushing them apart, something mysterious, something powerful. A faint purple haze spreads across space, pushing galaxies away. This is dark energy, a force stronger than gravity, a force that fills the entire universe. The narrator continues. While dark matter pulls things together, dark energy pushes everything apart. The camera shows one galaxy glowing quietly. Slowly it drifts away from another galaxy, then faster still. Dark energy makes up nearly 70% of the entire universe. A giant purple sphere represents dark energy, swallowing all other parts of the universe. Yet no one knows what it is. No one knows where it comes from. No one knows why it is there. Star universe controlled by the unseen. The narrator speaks gently. For the first time, humans realize they understood almost nothing about the universe. The screen splits into two halves. Left, visible matter, stars, planets, galaxies. Right, invisible universe, dark matter, dark energy. The narrator explains. The visible universe is only the surface. The real universe is hidden underneath. He pauses. It is like living in a house and discovering the foundation, walls, and roof are made of something invisible. The scene zooms into the Milky Way again. A dark halo surrounds it, glowing faintly. Our galaxy swims in a sea of dark matter, shaped by an ocean of dark energy. The narrator adds, everything humans see, every star, they only see the decoration. The universe's true structure is hidden. Star how dark matter shapes our existence. A slow montage begins, nebulae forming stars, planets spinning into place, galaxies gathering into clusters. Without dark matter, galaxies would never have formed. Stars like the sun would not exist. Earth would not exist. Life would not exist. The narrator continues. Dark matter is the silent architect of creation. The camera shows dark matter filaments holding galaxies in place as the cosmic web organizes the universe. Humans believe they live in a universe of light, but the real universe is built from darkness. Star how dark energy shapes the future. The camera zooms hundreds of billions of years into the future. Galaxies drift apart until they can no longer be seen from each other. If dark energy continues to grow, the universe will become more empty with time. Galaxies will move too far apart to see. Stars grow dim, space becomes cold. In the distant future, galaxies may live alone, a lonely universe ruled by dark energy. The narrator deepens the mystery, but this is only one possibility. There are others. A screen shows three futures: endless expansion, big rip, dark energy, decay. The narrator explains in simple words. In one future, the universe expands forever, becoming cold and dark. In another, dark energy grows so strong it tears galaxies, stars, atoms, even space itself, apart. In a third, dark energy weakens and the universe slows down again. None of these futures are certain. Star, the universe's greatest secrets remain hidden. The screen now shows a long cosmic tunnel filled with floating galaxies. Dark matter and dark energy are the greatest mysteries of the universe. They cannot be seen, cannot be touched, cannot be measured directly. Yet they control everything. They shape the past, they control the present, they will decide the universe's future. A dramatic pause follows. The universe is not what it appears. It is far deeper, far stranger, far more mysterious. The narrator lowers his voice. He has explored the birth of everything, the power of black holes, the invisible forces that shape the cosmos. The screen slowly zooms out until the visible universe becomes a tiny glowing bubble surrounded by darkness. But one question remains. How will the story of the universe end? Fade out.